Today, we'll go through how to pick the right N6700 series modules for your application. I'm Brian Whitaker, a product marketing engineer here at Keysight.
And I'm Daniel Bogdanoff, a Test Gear Geek here at Keysight. So there are a lot of modules, including this devil module. Talk me through why there are so many and which ones do what.
This is because ATE tests can vary in terms of power required and accuracy. In addition, test criteria can change quickly. N6700 is perfect for this because you can easily mix and match power and performance levels in one mainframe. There are over 35 different modules to create a solution optimized to meet your specific test requirements. These modules are divided into multiple categories, which I will go through, including SMU, Precision, Electronic Loads, High Performance, and Basic. Let me start with the N6780 SMU series. It is valuable for applications where multi-quadrant operation and high precision are required, and the module was designed for battery drain analysis. These SMU modules feature highly accurate measurement capabilities while operating as a DC voltage source, a DC current source, and electronic load. I'm going to demonstrate the measurement capabilities using Keysight's battery emulation software and a Wi-Fi enabled smoke detector. So why don't we grab the smoke detector?
Okay, so a SMU, or a source measure unit, supplies power, and it's also really good at the measurement part of SMU.
Yes, absolutely.
What are we doing here?
Okay, so I have Keysight's battery emulation software pulled up here. This smoke detector uses a CR123A battery, so I have a battery model pulled up within the battery emulation software that will emulate that battery, so we'll be able to power the battery basically from the software.
Okay, so our SMU is pretending to be the battery,
Right.
And it's hooked into the back here where the battery would normally go.
Right.
But our smoke detector thinks it's running off a battery, and we can see how it performs at like different charge levels.
That's right. So this chart will track the voltage and current levels of the device. So now let me go ahead and hit start. Oh, there you could hear it turn on. There you could see the current spike. So it drew about 108 milliamps. Now it's initializing, so you can see the LED flashing.
So as the yellow is toggling, that corresponds to the power consumption of that LED.
Yep.
Okay.
So now it goes into a lower power state where it's just taking measurements. It's both a CO2 and a smoke detector. So there are two different types of measurement levels here that you can see. And then every once in a while, it'll connect to the Wi-Fi network, which you just saw there. So let me go ahead and hit stop here. And now, let me just zoom in a little bit here. So here you can see, when it connects to the Wi-Fi network, it's almost 2 milliamps. But when it's just taking measurements, it's down in the microamp range and the nanoamp range.
So it's in a sleep state, nanoamp consumption, and then we go up to milliamp consumption when it's pinging Wi-Fi or checking carbon dioxide or whatever it does.
That's right. So the SMU module can measure from nanoamps to amps. And also it can do that in one measurement suite with Keysight's seamless measurement ranging capability. So there are no gaps in the measurement.
No dead time when it switches relays or something like that, like the old school power supplies would do.
Yeah. One additional thing to note is the software does offer an API to facilitate integration into your programming environment.
So we looked at the IoT device with an SMU. On the other side over here, we have an electronic load. What are people doing with electronic loads?
So they're great for power supply testing. So Keysight offers the N6792 series modular electronic loads with both a 100 watt module and a 200 watt module, each in a 1U footprint. The 200 watt module does take up a 2U slot in the mainframe, similar to this one. 4 different user operation modes are available: constant voltage, constant current, constant resistance, and constant power, which allows you to adapt to various load conditions needed for power supply testing. With a highly accurate measurement system with digitizing capabilities, users can easily gain insight into their power supply test. In addition to power supply testing, electronic loads modules can be used in combination with a power supply module to streamline the testing of DC to DC converters, which takes us to the N760 series of precision DC power modules.
So we have a precision module next to our electronic load. What makes it a precision DC module?
These modules provide precise control and measurements in the milliampere and microampere region, with the ability to simultaneously digitize voltage and current and capture those measurements in an oscilloscope-like data buffer. With both the N6762A and N6791A modules sold, you're able to easily run tests of a DC to DC converter.
We have both of those installed, and we have a DC to DC converter. We can run a test.
I think so. Let's do it.
So our DC to DC converter is hooked up to our electronic load and our power supply. And you have Excel open.
I do.
What are we looking at?
So this is an example where I've embedded a Skippy sequence using Command Expert into Excel.
Okay.
Yeah.
Can you just hit run in Excel? I see a run button.
Yeah, if I hit run, it'll actually run the full sequence.
So hit run and then talk me through what it's doing.
Okay, absolutely. One thing to note is I do have an input voltage setting, so 8 volts. So I could change it to 22 volts, 14 volts, etc. And it would run the test at those voltage inputs.
Okay.
But let's see what the efficiency curve is here, for example, for 8 volts. So what you see here is at first I have it set at an 8 volt input. So I'm going to generate an efficiency curve at 8 volts. Then it'll sweep the current draw from 1 amp to 3 amps and generate an efficiency curve.
Automatically.
So here you'll see the efficiency versus the current draw.
Okay, and that's why we need the supply and the load.
That's right.
Because the load can increment the current.
Right.
And the supply provides the power, and we have measurement through this whole system.
Right.
We automatically get a graph.
Yep. So this data is from the test at an 8 input voltage. So let's see what it's at 10.
So the 10 volt input, current sweep.
Yep. Current sweep. We'll see what the efficiency curve looks like.
Still blows my mind you can just do that right in Excel. Like,
yeah, pretty cool.
we have other ecosystems in which that works and it's automatic, but to do it in a program like that feels very useful.
Pretty cool. So here you can see the sequence was completed, and then boom, here you can see an updated efficiency curve. So pretty cool, huh?
Yeah, even better efficiency at 10 volts than at 8 volts.
Yep.
So when else would you want to use a precision DC power supply module?
So the N6760 series is also ideally suited for semiconductor and passive device testing, or where a precisely controlled output and highly accurate, precise measurements are needed during the test.
So that's the precision modules. I see an N6750A series high performance module. What would you go high performance? What are those for?
You know, when your throughput is your key concern, these modules provide low noise, high accuracy, and programming speeds that are 10 to 50 times faster than other programmable power supplies. For this supply, Keysight offers high-speed test extensions, which offers an oscilloscope-like digitizer that simplifies system configuration and increases measurement accuracy when viewing high-speed transient or pulse events within the DUT. So now, why don't we check out that transient speed?
Okay, what do we need?
Let's switch up the DUTs and use the thermostat DUT to measure the transient speed.
It's over there?
Yeah, let's go grab it.
Okay. So we have our thermostat. It's hooked up to both the power supply and the oscilloscope. And if we got our triggers right, when you hit run on your sequence, this should turn on and our oscilloscope should capture the rise time. And we can see how fast our rise time is. So go ahead and hit run and let's see if it worked.
Let's do it.
So 116 microseconds feels really fast for a power supply. Why would somebody want that fast of a rise time?
Throughput, right?
Okay.
1 second of throughput can cost thousands of dollars. So every millisecond counts. Another key stat is the N6700 series can support command processing times of less than 1 millisecond. So that's the amount of time it takes to actually send the command. So you have to consider the output response time and the command processing time when you're thinking about throughput.
Okay. And then we have the basic supplies. Tell me a little bit about those.
Sure. The Keysight N6730, 40, and 70 series of basic DC power modules provide programmable voltage and current measurement and protection features, making these modules suitable to power a DUT or to provide power for AT system resources, such as fixture controls.